Using rates. Learning goal. I can explain what a rate is, when rates are used, and why you can describe the same rate in different ways. Let's look at an example. There are 625 students, and we need to have classes with no more than 25 students per class. How many classes will we have? Well, the key that this is a rate problem is you see the word per. So whenever we're talking about something per something else, we're typically talking about kind of a rate. Now this is maybe a different rate from what you might be used to when you think of a rate of travel when you're moving at kilometers an hour, but it's still a rate. It's students per class. So if we know we've got 625 students and we have to break them up into groups of 25, we're simply dividing 625 by 25. If we do that math, we can do it mentally or we can do it in long form here. Mentally, I remember that 5 times 25 is equal to 125, and another multiplying that times 5 is going to give me 625. So that means I've got a 5 times a 5, so I've got 25. Just to confirm it in the long form, number of 25s go into 62, 2 times, giving me 50. Subtracting that, I get 12, bring down the 5, and I get 5 times 25 is 125, with a remainder of 0. So I do get an answer again to confirm that it's 25. So in this case, we would have 25 classes. Let's look at a simpler problem. Suppose you can walk at a rate of 1 kilometer every 12 minutes. How far can you walk in 24 minutes? Hopefully most people can see that if you've walked 1 kilometer in 12 minutes, then you'll be able to walk twice that far in 24 minutes. So now, in 24 minutes, you've gone 2 kilometers. So this is a very useful tool when you're trying to work with rates, is having 2 number lines superimposed together. So here we had a distance number line, and on the bottom we had the time number line. By putting them together and matching them up, it helps us to interpret more. Let's look at another related example. Now suppose you can walk at a rate of 1 kilometer every 12 minutes, just like before. Now they want to know, though, how far do you walk in just 1 minute? Well, again, the number line can help us. The 2 number lines can help us. So again, on the top, we've got distance, and on the bottom, we've got time again. So they match up here at 12, and now we can go ahead and interpret. We can see that, obviously, at 6 minutes, we'd have walked half a kilometer. In 1 minute, how far have we walked? Well, if you think about it, by breaking up the bottom line here into minutes, it also serves as an increment of breaking up this 1 kilometer stretch into 12 segments. So, if we walked 1 kilometer in 12 minutes, we walked half a kilometer in 6 minutes, because that's half the time. That means in 1 minute is equal to 1/12 of the total time. So we'd walk 1/12 of a kilometer in 1 minute. Over on the side here, you can see that I wrote the rate in the way we typically do it, where we put 1 kilometer with a slash and then 12 minutes. So 1 kilometer in 12 minutes. But if you just go a little bit further, and again, keep in mind that it's like a division problem, and you put them one right on top of the other, then you start to see you've now got a fraction here that says 1/12. And in fact, it says 1/12 of a kilometer per minute. Let's look at another rate. If eggs cost $5.04 per dozen, how much does each egg cost? So they're telling us that for $5.04, you get a dozen eggs, and a dozen, of course, is 12 eggs. If we want to know how much each egg costs, we've got 5.04 divided by 12 eggs. This is dollars. $5.04 for 12 eggs. You can see now that we effectively have a division problem here. 5.04 divided by 12. Doing long division, 4 times 12 is 48. To put a decimal up there, subtracting 50 minus 48 is 2. Bring down the 4. 2 12s are 24. Subtracting gives me a remainder of 0. So in this case, each egg costs 42 cents, or 0.42 of a dollar. Let's look at another rate problem, this time going back to a speed-related type problem. So we're bicycling at 15 kilometers an hour, and they ask us, how far can we go in 2 hours? Well, one way would be to draw out the number line, but we can also do some other types of math here. If we've got 15 kilometers an hour, that means we go 15 kilometers in 1 hour, but we're going for 2 hours, so fairly straightforward. We've got 15 kilometers per hour times 2 hours. The hours cancel out, and we end up with 30 kilometers. Second part of the question asks us, how far do we go in half an hour? I can use that same approach, 15 kilometers times 0.5. That's kilometers per hour, and this is hours. Half an hour times 15 kilometers, so again the hours are going to cancel out, so I just have 0.5 times 15. You can also think of that as 15 divided by 2, which of course is 7.5 kilometers. Okay, now we've got another similar question. Again, we're riding our bike at 15 kilometers an hour. Our odometer says we've traveled 5 kilometers. How much time did it take us? Well, the key thing we're looking for is this time we're looking for an answer in time. So that means we want an answer in minutes or hours. But we've been given a speed in kilometers per hour, and we've got a distance traveled in kilometers. So how are we going to get this answer down into time? Well, since we know we want to end up with time, and we've been given something in kilometers an hour, if we flip kilometers an hour upside down, we end up with hours per kilometer. And if you think about it, that will then help us because we know how many kilometers we went. So if we know how much time it takes to go 1 kilometer, then it's very easy to say how far we went to go 5 kilometers. We just have to multiply that answer by 5. So how are we going to get to hours per kilometer? If we've got 15 kilometers per hour, we can flip that upside down, and it means we have 1/15 of an hour per kilometer. If we're going to multiply that times 5, we're going to end up with 5 times 1/15, which is the same as saying 5 divided by 15, which I think most people would pick up on to say that is 1/3. So we've got 1/3 of an hour. Well, 1/3 of an hour, if you're not sure about what that is, 1/3 of an hour means 1/3 times 60 minutes. Third of 60 minutes is the same as saying 60 divided by 3, which is, of course, equal to 20 minutes. So that gives us our correct answer. The first step was to figure out how many hours per kilometer we go. In this case, it's a fraction of an hour per kilometer. And then we multiplied that by the number of kilometers that we traveled. The final step was to convert it into minutes, which arguably wasn't necessary, but 1/3 of an hour, not everybody is going to intuitively understand what that means, so converting it to minutes is a much more meaningful answer. Lesson summary. A rate is a lot like a ratio, except that it involves two quantities measured in different units. A running rate is 5 kilometers per hour. A price rate is, an example, $5.99 per meter. A sleeping rate is 8 hours per day. Equivalent rates can be determined in the same way as equivalent ratios, by multiplying or dividing both parts by the same non-zero value. For example, running 5 kilometers in 1 hour means that running 1 kilometer should take 1/5 of that time. 1/5 of 60 minutes is 12 minutes. So, 5 kilometers per hour is the same as 1 kilometer every 12 minutes, or 1 kilometer per 12 minutes. Equivalent rates can also be determined by changing the unit used. For example, to find an equivalent rate for 1 kilometer per 12 minutes, change 1 kilometer to 1,000 meters. Then you have 1,000 meters per 12 minutes. In 1 minute, you would go 1/12 of the distance, or about 83.3 meters per minute. Key terms. Equivalent rate are the rates that describe the same comparison. For example, 4 for $1 is the same as 1 for 25 cents, or 1 for a quarter of a dollar. Equivalent ratios are ratios that describe the same comparison. For example, in a group of 8 adults and 6 children, the ratio of adults to children is 8 to 6, or you can reduce it down to 4 to 3. Rate is a comparison of quantities that are in different units. For example, $2 for 6 items, or 80 kilometers per hour. Ratio is a comparison of 2 or more quantities. For example, if there are 5 adults and 3 children in a group of 8, the ratio of adults to children is 5 to 3, or 5:3. Your turn.